Hey guys, Mr. Bowman here. We are in Desmos at the moment, and I've input a formula that we looked at the end of last term. This was the factorized form where we can see three brackets, and each of those brackets indicating what the x-intercepts will be of that cubic. So we can see x minus 1, that means we're going to have a intercept of positive 1, and we can see that on our cubic. Then we've got x plus 2, we can see an x-intercept at minus 2, and then we've got x plus 5, where we can see an x-intercept at minus 5. And today's lesson, we're going to be looking at a different type of quadratic, and that is quadratics which are in the form of ax of a in brackets x plus b cubed plus c. And this is similar to the parabola formula that we looked at, which moved the graph around based off the vertex. But before we do that, let's have a quick chat about how this form looks and how that relates to our regular parabola. So our regular parabola, y equals x to the power of 2. So that's up there. And what a cubic or a regular cubic does, x to the power of 3, that changes the form a little bit. So on the left-hand side, it's pretty similar. It's going up at a steep rate. But on the right-hand side, but on the left-hand side, that side has been flipped upside down and has become negative. And the reason being, this side, the purple one, is always positive because negative 1 times negative 1 becomes positive 1. And down the bottom for the cubic, negative 1 times negative 1 times negative 1 is always negative 1. Hence why all those values become negative as opposed to positive. So let's delete that parabola. And just like the parabola, we've got a vertex, and that starts at point 0, 0. And the formula we've got above, ax plus b cubed plus c, that moves this type of parabola around based on the instructions that you're given. So let's have a look at an example. So let's try to move this parabola up 1. And just like our parabola, so let's try to move this cubic up 1. And just like our parabola, we did a plus c as a plus 1 to increase it by 1. So let's see if that works. There we go. So what we've done is, so it has worked, and we've moved it from the origin at 0, 0 to plus 1. So that plus c moves it up and down, just like it did for a parabola. So let's have a look. Let's try to move it down 1. So let's move it down 2, and then we can see it's dropped all the way down to minus 2. So that c moves it up or down. Okay, so that's c. Let's have a look at b. What does b do? And b, just like a parabola, it moves it left or right based on the point. So let's try to move it to the left to negative 1. And the opposite of negative 1 is positive 1. So that means our bracket needs to become positive 1. And let's see if that works. Perfect. And we can see that's been moved to the left, positive. So it's been moved to negative 1 by having plus 1 in our brackets. And let's try to move it to positive 1. And the opposite of positive 1 would be negative 1. Minus 1. So hopefully that moves it for us. And there we are. We can see that our new purple line, it's been moved to negative 1. So just like a parabola, the number inside the bracket, or that b, it moves it left or right based on the negative value of the number that sits in the bracket. And what we can do is we can combine b and c. So let's try to move it up to negative 1, positive 1, just over here. So just zoom back out again. So negative 1, positive 1 is what we're aiming for. So to do that, x, we want to move it to the x-axis, positive 1, and that relies on the opposites. So let's do plus 1 cubed. Cubed. So we've moved that to the left 1. And let's try to then increase it by 1. And that's moved it up by 1 as well. Okay, so we moved it just like that. And our final bit of information is that a what does that a do? And like a parabola, the a can make it skinnier or fatter as well. So for a parabola, if we did y equals 2x cubed, we would expect that parabola to become a lot steeper. And we can see that with the red parabola compared to the black parabola. Because it's 2x cubed, the rate is going up at a bit of a faster rate than compared to the x squared. And conversely, if we did it as a fraction, let's say 0.5 or a half, we would expect it to go up at a slower rate. So we'd expect it to be a bit fatter, a bit wider. And we can see that again, the black line, it's going up at a slower rate, and it's now that blue line. And just like a parabola, we can turn them upside down by making them negative. So there's a negative parabola, and we can do negative 2x cubed, which made the negative one skinnier. And finally, we can do negative 0.5x cubed, which makes the negative one fatter or wider. So what we've done is we've been using this formula, ax plus b cubed plus c. We can visually find b and c by looking at the graph, and we then have to calculate a using the point in our graph. And I'm just about to switch screens to show us how to calculate a. Okay, I've got a new graph and I've switched screens. I've also written down the formula that we're going to be using up the top. So our first step, we always want to write down the formulas that are relevant to us. So I'm going to copy down the formula that I've just got in green. And we want to figure out what is the plus c and what is the plus b. And we're going to follow our cubic. The flat point in the middle of that, that's our kind of the equivalent of the vertex. That's the point that would have started at 0, 0. And we need to find out what those coordinates are, because that helps us with our value. So the first one is, how much has it moved up or down? It's been moved down negative 2, which means that c is going to become minus 2. It's been moved to the left 1, so it's been moved to negative 1 up the top there. And the b value would be the opposite value of that, which would be plus 1. So that plus 1 would move that Okay, so I've finished writing up my formula. So far I've got y equals a, and then in brackets x plus 1 cubed. So that plus 1 moves it to minus 1. And then minus 2, and that minus 2 moves it down to minus 2. We now need to find or substitute in a point to get an x and a y value to then be able to calculate the a. I've got a point highlighted on our screen for us just there. So at that point, or the y-intercept, it was 0, negative 1.25. So at that point, that means x is equal to 0 and y is equal to negative 1.25. We're going to substitute both of those in to calculate a. So negative 1.25, that is equal to a, 0 plus 1 cubed minus 2. And we're now going to use our algebra skills to solve from that. So first thing is 0 plus 1 is 1. And we cube that, that's just 1. So we've got negative 1.25 of a minus 2. We're then going to move that minus 2 over to the other side as plus 2, which becomes 0.75 is equal to a. And as a fraction, a is equal to 3/4. And that means we can wrap up our formula. So y is equal to 3/4 of x plus 1 cubed minus 2. Hopefully you found this video. Now let's get into some more questions.